Everyone, so this is lecture 7 and we're going to discuss equations and inequalities. So we're going to start first by factorizing algebraic expressions. Then apart from that, we'll also look at equations and inequalities. Then we'll conclude everything by looking at linear equations. Alright, so let's quickly dip into business. Alright, so factorizing algebraic equations. So I'm going to start first by showing you, or simply just reminding you what you already know. So if you have y is equal to, okay, let me not use 1, let me just say, if you've been given a question like 2x plus 8y, they ask you to factorize this. You are going to get the common function, there will be 2, then open brackets, in brackets you're going to have x plus 4y. If you have a question like maybe xy squared plus 2x, they ask you to factorize this. You're going to get the common function there is x, that's the common variable, then you remain with y squared plus 2. Now what if they ask you to factorize x squared minus y squared? This is what we're going to discuss. Or maybe x to the power 3 minus y to the power 3. This is what we're going to discuss. So if you've been asked to factorize x squared minus y squared, so this one is called the difference of two squares, meaning you first have to write x plus y and you multiply it with x minus y. So this is what you're going to have as your solution. So if you have maybe for instance 2x in brackets squared minus y squared, this is just going to be 2x plus y and then times 2x minus y. So this is what we mean by the difference of two squares. So you can also have maybe 9x squared minus 9x squared minus okay, let me not use 8, let me just say 4 minus 4. So this can also be written as 3x squared minus 2 squared. So this one becomes the difference of two squares, which can be written as 3x plus 2 and 3x minus 2. So this is what we mean by the difference of two squares. So let me just show you what I meant. So this is exactly what I was just explaining. And then the other thing you need to look at is the difference of two cubes. So when you have the difference of cubes or the addition or the sum of cubes, this is what happens. So you just write, if you have x cubed plus y cubed, you just have to write x plus y in brackets, and then you write x squared minus xy plus y squared. So this is what it means. Same applies to the difference of two cubed. You just start with x minus y, then there the sign will change it to be a plus. Alright, let's look at some examples. We have this example here. So this example is simply just 9x squared y squared minus 64. So this we're going to make it in the form of a difference of two squares. So this 9 can be written as 3 squared, then we have x squared, then we have y squared minus. So this one 64 can be written as 8 squared. Then this can also be written as 3x y, we factor out the square and then we write the square outside there, so we have 8 squared there. So this can also be written in the difference of two squares as 3xy plus 8. So you can either start with the one with minus and end with the one with plus, or you start with the other one and end with the other one, there's no problem. So we have 3xy minus 8 is the answer. So this is the final answer, the difference of two squares of this question. What of this other question? We have this one. Okay, the difference of two cubes. We have x to the power 3 then minus 8. So 8 can also be written in terms of power 3 as 2 to the power 3. So using the difference of two cubes, we say the answer will just be x minus 2. I don't know why this, let me just write it properly. So we're going to have x minus 2, then in brackets we have x squared, then plus there we have this 2 times x, which will be 2x, then we have plus 2 squared. So we're going to have x minus 2, then you have x squared plus 2x, then plus 4. So this is exactly what it means when they ask you to factorize such expressions. So it's not something that is so difficult. You just have to master these formats, in short. Okay, so let's quickly move on and check the other examples. We have this example there. So this example is also straightforward. We factorize 2 there. 2 is common, so we're going to remain with x to the power 3, and then minus 2 into 54, that is going to be 27, and then everything divided by x squared plus 3x plus 9. So we can see that on top there we can express 27 as the power of 3, to the power 3. That is going to be, so we have x cubed minus 3 cubed. So everything divided by x squared plus 3x plus 9. So this can also be written, we can factorize the numerator there using the difference of 2 cubes. So that can be written as 2 outside, and then in brackets we open, say x minus 3, then we open another set of brackets, say x squared, then plus 3x, then plus 3 squared. So this we divide it by x squared plus 3x plus 9. So this can also be simplified to x minus 3, then open brackets we have x squared plus 3x plus 3 squared is simply just 9. So when you look at that and the denominator there, this will cancel. So we can cancel this, we also cancel that. We just remain with 2 open brackets x minus 3, then everything divided by 1, which is just the same as 2x minus 3. So these questions are simple, you don't have to take time to solve them. Okay, let's quickly move on to the next one. So we have another one, which is this one. So this one is also simple. Let me start it from there. We have 7 minus y, which can, okay, let's arrange this in this format, meaning we have negative y plus 7 on top, which can, and then the denominator there can be written in terms of the difference of 2 squares, which is 7 can be written in terms of squares. 49 can be written in terms of 7 squared. Yeah, it can be written as 7 squared. It's the same. So on top there we can factorize the negative 1, which is outside y this side. We want to leave y to be positive. So when you factorize negative 1 there, or when you factorize a negative there, let me just say negative 1 there, we're going to have inside y and then negative 7 there. And then everything divided by the difference of 2 squares there can be written as, sorry, not really x but y. You can write it as y plus 7 and y minus 7. So you can see that this and that will cancel, meaning we just remain with negative 1 on top. Down there we have x plus 7. Sorry, not x but y. We have y plus 7. So this is the answer, as simple as that. Let's look at the other question. Oh, we have equations. I thought there is another example. So we have equations and equalities. So the equalities, first of all, let's look at examples of equations. So for something to be called an equation, it needs to have an equal sign somewhere. So when you have something like this, because of this equal sign, we'll call this whole thing as an equation. So when you have something like this is just a function. If there's no equal sign, it's just a normal function. It doesn't have an equal sign. But once you introduce an equal sign, it becomes an equation. So you can also have examples of equations like this. This is also an equation. You can also have y is equal to 2x plus 3x to the power 3 plus 1. This is also an equation. So equations should always have an equal sign somewhere. Then we also have types of equations. We have quadratic equations, we have linear equations, we have polynomial equations. Yeah, so it depends with what equation you're dealing with. So for a linear equation, you have something that is in this format. So this is a linear equation. Why do we call it a linear equation? Because the power of x is 1. When you talk about quadratic equation, the power of x is 2. When you talk about polynomials, so a polynomial is any function that has a degree that is greater than 1. So even a quadratic equation is a polynomial with the degree 2. So we have other polynomials with degrees maybe 3, and then we have bx squared plus cx plus d. So this is a polynomial. Even just x to the power 3 minus 1 is a polynomial. Alright, so let's quickly see what is. Yeah, so this is what I was just writing. I was just explaining. It's an equation. So let's look at the properties of equality. So I'll start by explaining the reflective property. The reflective property means that if A is equal to A, this one is straightforward. A is equal to A, it will still be A is equal to A. This one is just straightforward, it's self-explanatory. Then we have the symmetric property. We know that if A is equal to B, you will definitely also understand that B is also equal to A. If we say A is equal to B, it means that B is also equal to A. This one is also straightforward. Then we also have the transitive property, which says when A is equal to B and B is equal to C, it means that A is equal to C. When we say A is equal to B and this B, the same B here, is equal to C, it means that A is also equal to C. It's just the same as saying BMW is a car, and we also have what's this? And we also have we say BMW is a car. Then we also have Benz. Benz is also a car. Meaning, if we have BMW to be a car, we also have Benz as a car. Then you also have another parameter, which is let's say we get what's this? What other car do we have? Okay, let's just say, I don't know, the names of cars have gone in my head. Alright, so we also have maybe Lamborghini as a car. So Lamborghini is also a car. Okay, not really Lamborghini. Okay, let me say, okay, I think this example will not make sense. Let me just say, if A is a dog and B is also a dog, and A is equal to C, this means that, okay, if A is equal to dog, B is also equal to dog. Then if we say A is equal to B, if we say A is equal to B, it means that, okay, let me say A is equal to C, it means that B is also equal to C. Alright, but this is also straightforward. In short, let me just write it the way it is. We have A is equal to B, then we have B is equal to C. It means that A is equal to C. Yeah, so when you have A is equal to a dog, and then you have B is also a dog, it means that a dog is equal to a dog, in short. Yeah, so that's what I was just supposed to say. Alright, so we have this other property where we say A is equal to B, this one here, when A is equal to B. So for something to be, for something to qualify to be an equation, it means that whatever that we do this side on the left, we also have to do it on the right. So if we add C on the left, C should also be added on the right. That's what it means by an equation. So the same applies to the last part there. If we have A is equal to B, if we multiply C on the left, we also have to multiply C on the right. That is what it means by these equality equations. Alright, so let's quickly move on to some examples. So let's look at this example here. So we have 2x plus 3. 2x plus 3 is equal to 7. So we take this 3 to the other side of the equal sign. We're going to have 2x is equal to 7 minus 3. So 2x is equal to 7 minus 3, that will give us 4. So 2x is equal to 4. When we divide everything by 2, we get the value of x to be equal to 2. That is exactly how you solve such an equation. So the other thing that we need to understand here is that if you are dealing with maybe basic mathematics, you don't just say you take this to the other side of the equal sign. You have what we call the additive inverse. So when you have 2x plus 3 is equal to 7, you find the additive inverse of 3, that will be negative 3. So you have 2x plus 3. So we add negative 3, we add the additive inverse on the left. It means that this same additive inverse, we're going to add it on the right. Remember that property I showed you? So we're going to have 2x, 3 minus 3 this side will give us a 0. So we have plus 0 there. Then 3 minus 7 minus 3, we get 4. So we remain with 2x is equal to 4 over 2 over 2. The value of x becomes 2. So this is what it means when you are dealing with equations. Okay, let's move on to the other one. So we have 4n minus 4n minus 2 minus 3n minus 1, 2n plus 6. Okay, so even this one is straightforward. So this one we multiply, we open the brackets, 4 times n there, we get 4n, minus 4 times 2, we get 8, we say negative 3 times n, we get negative 3n, negative 3 times negative 1, we get positive 3. This is equal to 2 times n, we get 2n, 2 times 6, we get 12. So we pair the like terms now. We collect the like terms. We have 4n and 3n there, so we can write 4n and negative 3n there. Then we can also write negative 8 and positive 3. So negative 8 and positive 3. This is equal to, we have 2n plus 12. Then from there, 4n minus 3n, this will just give us n. And then we have negative 8 plus 3, we get negative 5 is equal to 2n plus 12. That will be 2n plus 12. So we pair the like terms again. So we're going to take this n to the other side of the equal sign, or we take it to the other side. Or we take this on the right, and then we take 5 to the we take 2n to the left and negative 5 to the right. So when you take 2n this side, we're going to have, since it's positive, to become negative 2n. Then since negative 5 is negative, when it comes this other side, it's going to be positive 5. So so we have n minus 2n. The answer is simply just n minus 2n. The answer is simply just negative n is equal to 12 plus 7. This is 17. So we have negative n is equal to 17. So we say negative 1. We divide by negative 1 on both sides. So the value of n becomes negative 17. So this is exactly how you solve such equations. Let's quickly move on. So we have another equation. Which is just this one here. Okay, this one. This one is also straightforward. What you do here is that you just find the common denominator this side, which I believe is 12. So 12 is a common denominator. And then the other thing that you do after finding the common denominator, you divide 4 into 12, you get 3. So this 3 is multiplying with everything on top of 4. And then we say minus 6 into 12, we have 2. 2 is multiplying with everything on top there. Then this is equal to 2 over 3. So we can open the brackets on top. 3 times x, we get 3x. 3 times negative 1, we get negative 3. negative 2 times x, we get negative 2x. Negative 2 times negative 2, we get positive 4. Everything divided by 12 is equal to 2 over 3. So we can simplify this expression. 3x and negative 2x, you put them together because they are like terms. Then negative 3 and positive 4, you also put them together because they are like terms. And then everything divided by 12 is equal to 2 over 3. So 3x minus 2x, the answer is simply just x. Then negative 3 plus 4, the answer is simply just 1. Everything divided by 12 is equal to 2 over 3. So we can cross multiply. So 3 times that, we get 3 times x plus 1 is equal to 12 times 2, that is just 24. So 3 times x, we get 3x. 3 times 1, we get positive 3 is equal to 24. So this 3 will cross the equal sign. We're going to have 3x is equal to 24 minus 3. Then we have 3x is equal to 21. Then we divide by 3, then we find the value of x to be equal to 7. So this is exactly how you solve such equations. They are very simple and straightforward. Okay, so let's quickly move on to the next question. So the last question here we're solving today is this one. The average of the salaries of Kelly, Rini, and Nina is 20,000 a year. If Kelly earns 4,000 less than Rini, and Nina's salary, and Nina's salary is 2/3 Rina's salary. Okay, find the salary for each person. So this one is straightforward. Yeah, so we can first say okay, so these people in the context, in the text here, we're going to represent them with their first letters. So Rina will be represented by R, so we can say let R be equal to Rina, let N be equal to Nina, and then who else is there? And then K be equal to Kelly. So they're saying the average for the average salary for all these is 20,000. Alright, so the first thing that you need to understand is that they are saying the average is 20,000 a year. And then, yeah, so meaning when you add their salaries of that year, the answer is supposed to give you 20,000. Then if Kelly earns 4,000 less than Nina, so meaning we say Rina minus Kelly. So Kelly 4,000 less. So Kelly earns 4,000 less than Rina. Rini. I don't know if this is Rini. So Rini means that, okay, the statement is Kelly earns 4,000 less than Rini. 4,000 less than Rini. So we know to say R minus K is equal to 4,000. Then the other point we have here is Nina's salary is 2/3 Rini. So Nina's salary is equal to 2/3 of Rini. So we have this one as our first equation, then this one as our second equation. So we can solve these two equations simultaneously, but we need to also have the third equation. They are saying Rini is their average salary is 20,000. So this is going to be, okay, so they are saying the average is 20,000. So when we add R plus K plus N, everything divided by 3, this should give us 20,000. So here is just a matter of cross multiplication. So we know that this will be r plus k plus n is equal to 60,000. So we have n, which is equal to 2 over 3 r. So while there's n, we can put 2 over 3. Then we can also make r the subject, sorry, k the subject of the formula here. So when you make k the subject of the formula, this will just be k is equal to 4,000. When this r goes to the other side of the equal sign to b, so we have negative k there. This will remain negative k minus we have 4,000 minus minus k. Oh, sorry, not minus k. When we are trying to make k the subject, meaning we're going to say minus r when r crosses the equal sign. And when you divide by negative k, sorry, negative 1, that will simply just be the same as k is equal to r minus 4,000. Yeah, so while there is k, we put r minus 4,000. While there is n, we're going to put 2 over 3r. So we have r plus, while there is k, we put r minus 4,000. And then while there is n, we put 2 over 3 plus 2 over 3r. And then this is equal to 60,000. So r plus r, this will give us 2r. Then when you add it to 2 over 3r, when you find the common denominator and everything, you get 8 over 3r. Then this negative 4,000, you take it to the other side of the equal sign so that you pair the like terms. So this will be 60 plus 4,000, which will just be 64,000. So when you cross multiply here, you're going to have the value of r to be equal to 24,000. Yeah, because when you cross multiply, this will be 64 times 3, and then when you divide by 8, you're going to have 24,000. Okay, so after finding the value of r, you can now find the value of k. The value of k here is just going to be k is equal to, so r is 24,000, and you say minus the 4,000 here, which is so this the value of k will simply just give us 20,000. Then to find the value of n, you simply just have to replace r there. So I have r as 24,000. So if we're to replace r there, let me just do this. For to replace r there, we're going to have n is equal to 2 over 3. The value of r is 24,000 there. So 2 times 24,000, that's 48. Then when you divide by 3, that's 16,000. Yeah, if you want, you can start by dividing by 3. 3 into 24, that's 8,000. Times 2, that's 16,000. So just add the quaternions to show that you're dealing with money. Alright, so this is how you find the values of the values of r, n, and k, which are just the monthly salaries for these people. Okay, so we are done with tonight's lesson. Let's quickly move on, or rather, we're done with tonight's lesson. This is the end of the lecture. And in case you didn't understand any question, you're free to ask this to repeat the video. You're free to watch it for the second time. That's why it's recorded, so that you understand where you didn't understand. Thank you very much. See you in the next lecture. Shalom, shalom.